The PLC Professor website and PLC Professor YouTube channel offers you RSLogix5000, specifically creating multiple programs, and we're going to use conveyor logic as our example. In this presentation we're going to create some logic, and then we're going to discuss reusing the logic in another program. So first we'll go to File, New, and we'll leave it in L35E version 20, and we'll call this program Warehouse. Click OK. The geeks in the background are creating our program for us, our project files over here. First thing we need to do is to add some I/O. So I'm going to go down to Local Compact Bus, right click, New Module, and I have an IQ16. Double click on IQ16 and then type in DC inputs, for lack of a better name. Slot 1's fine. I'm going to change the module definition to disable the keying because I don't want to match up the firmware. And then we'll go up here and type in OB, and we want a 1769 OB16, and we'll just call that DC outputs. Slot 2's fine. We'll change the definition to disable keying, and then we close, and we have two I/O modules down there now. Let's collapse motion groups and data types. That gives us a little more space. And here's our hardware image: L35E processor, an IQ16, and an OB16. That gives us 16 inputs and 16 outputs to work with. So now let's create some program. So we go up to Main Program, double click to open up the main routine, and we're going to put in some code to control a conveyor. I'm going to pause in RSLogix5000 for a minute and explain the application, and then come back right to this point. We're doing multiple programs, which means multiple databases. One of the beauties of RSLogix5000, or rather of the Logix Engine that you create programs for with RSLogix5000, is that you have a granularity available to you that is equivalent to 3200 MicroLogix or SLC 500 type applications, meaning each PLC normally has its own database that includes I/O data and internal data. With the Logix Engine, you have one external database, or I/O database, one database that's called controller tags, and it has basically access to the outside world through the backplane and to programs in the controller. And then you have individual programs, and each program has its own database. So for our example, we're going to use a conveyor. So here we have three sections of conveyor. To the left you have a roller gravity fed conveyor, and then in the middle you have a buffer conveyor, and then to the left you have a takeaway conveyor. Now it really doesn't matter what this conveyor is used for, but the basic idea is that production containers or boxes, containers of products, will appear on the left side, come down the gravity conveyor, and then come to rest against the edge of the buffer conveyor in the middle. So product is going to be traveling from left to right. If the middle conveyor, the buffer conveyor, turns on, it will pull cartons onto the belt and away from the gravity conveyor. To the right, you have a takeaway conveyor that's going to take away those cartons to another part of the process. So the basic idea here is to buffer cartons of material, containers or cartons, and we want to be able to buffer at least 4 of them on this middle conveyor. So as they drop down the gravity conveyor, we want to put them on the conveyor one at a time until there's 4 on there, and then we don't want to take any off on the takeaway conveyor unless there's at least 4 buffered. So here we have a carton, and it's going to come down and rest against the buffer conveyor. When the buffer conveyor turns on, it'll take it over and it'll rest against the takeaway conveyor. And when the takeaway conveyor comes on, it'll pull it on the belt and take it away someplace. To do this, we're going to need some equipment. We're going to need a couple photo eyes. We're going to need a couple conveyor motors. So we have 4 photo eyes and we have 2 conveyor motors. So as our carton comes down the gravity conveyor, we also want to add a stop. That requires an output type device like a solenoid valve that controls an air cylinder that pushes a blade up in between 2 of the rollers to block cartons from going any further down the gravity conveyor. So when a carton comes in, it hits the stop, and when we're ready for it to enter the buffer system, the stop goes down by energizing the solenoid, and it breaks photo eye 1 PE, and comes to rest against the buffer conveyor. When the buffer conveyor is ready, it turns on, pulls a carton through 2 PE, it breaks 3 PE, and rests against the stationary belt of the second conveyor, the takeaway conveyor. When the takeaway conveyor turns on, it pulls it through 4 PE and out of the system. Okay, we're also going to add a barcode scanner. That way we can identify what product is coming out of the system and onto the buffer conveyor. So here's our carton. It's scanned. The stop drops. It runs through 1 PE, 2 PE, 3 PE, 4 PE, and on through the system. However, we want to buffer up to 4 cartons at a time on that middle conveyor section. We're going to add a couple more devices. Our conveyor motors each have an encoder or a pulse generator attached to the output shaft or the drive shaft of the conveyor. And basically this PG, pulse generator, will put out a symmetrical pulse, or it could be asymmetrical, but it'll put out a pulse for every so many increments in inch that the conveyor belt travels. Now it's actually putting out a pulse based on the rotation of the shaft, but the rotation of the shaft can be directly correlated to the circumference of the drive pulley. So if the drive pulley is 12 inches in circumference, that means it makes 1 complete rotation for every 12 inches that the belt travels, and the pulse generator puts out 6 pulses per rotation. You'll get a pulse every 2 inches of travel on the belt. Now that can be adjusted to anything. So in our example here, we're not trying to completely tidy up this example and make it perfect and copyable for use out in the field, but the techniques that we're illustrating hold true. And then the takeaway conveyor, the second conveyor, also has a pulse generator. This is the hardware image. So we have a scanner, barcode scanner, that reads the cartons, the barcode on the cartons, and if it's a legitimate code and the system is ready to accept a carton, the solenoid 1SOL is energizes and pulls the stop down and lets the carton travel down the gravity conveyor until it breaks 1 PE and rests against the buffer conveyor, the first conveyor there, 1 CNOV. When the middle conveyor, the buffer conveyor, turns on, it's going to pull the carton through the photo eye, 2 PE, and the idea is to pull it onto the middle conveyor until it just clears 2 PE and then stop. So if we do that continually, we should be able to get 4 cartons or containers onto this middle conveyor section before it's full. And then of course, as the cartons leave the buffer, they're going to break 3 PE as they travel over to the takeaway conveyor. As they're pulled onto the takeaway conveyor, 4 PE will be broken. So let's run a carton on here. Okay, while we're at it, we're going to talk about data types. So the scanned code from the scanner, I'm going to declare that as a double integer data type. Now it could be a string or ASCII, but we're going to keep it simple and just make it a 32-bit double integer. So if this code is good, then the system is going to energize the stop solenoid, which is going to pull it down, and it's going to break 1 PE, which is PE gravity. It's the exit of the gravity conveyor, and it's a photo eye, so we call it PE underscore gravity exit. Now the reason I always put PE in front instead of behind in the tag names is that way all the photo eyes are accessible in the same spot alphabetically in the tag database. Once the carton is ready to be pulled onto the buffer conveyor, then we will energize that motor, which is going to give us pulses generated. It also breaks the photo eye buffer entrance, or the buffer entrance photo eye, which is a Boolean type data type. Boolean data type means it's a bit. Notice that the motor buffer conveyor is also a data type Boolean. The pulse generator is also a Boolean, but that pulse generator is going to be used to drive the data buffer conveyor, and that data type is an array of 20 double integers. So picture, if you can, that the conveyor in virtual space is an array of 20 double integers, and each double integer of the 20 represents a space on that conveyor belt. By taking the scanned code, which is a double integer, and shifting that scanned code along the data buffer conveyor to create a virtual image of the actual box conveyor, the buffer conveyor, we create a data image of the entire system. Okay, once we are ready to send cartons out, of course the buffer exit photo eye is blocked right now, but as we pull them away, we break the beam of 4 PE, which is PE takeaway entrance, or the takeaway entrance photo eye, also a Boolean data type. The motor was a Boolean data type, the takeaway conveyor motor, and that motor is going to drive the takeaway conveyor pulse generator. And that pulse generator is going to drive code that again creates a data conveyor that is a mirror image of the actual carton that's on the takeaway conveyor. This is the data image of our process. Okay, let's take a look at this sequence of operation. We have a carton that comes out of the main production area. The scanner was good, it drops the stop and it sends it in. And as soon as the carton clears the second photo eye, meaning that it's all the way onto the buffer conveyor, then the system stops. Because remember, we want to accumulate at least 4 cartons on the middle conveyor, the buffer conveyor, before we take any off with a takeaway conveyor. Next carton comes along, code's good, it drops the stop, comes down and rests against the belt turns on and pulls it on, and stops as soon as that second carton has cleared the photo eye at the entrance of the buffer conveyor. Now keep in mind the spacing between these cartons is a function of several things. The first one is the speed of the buffer conveyor. The first carton on is going to move away at full speed, but it may take a few seconds for the belt to fully grab that second carton and get it onto the conveyor belt, plus the spacing between the photo eyes. So if the photo eye 2PE was to be moved a little bit further to the right, then each carton would be a little bit further onto the middle buffer conveyor before the conveyor stopped. So here comes a third carton. Good code, drops the stop, lets it come down against the belt, kicks on and pulls it on. Now if you see this space shrinking between the cartons in my animation, don't worry about it. It's just a function of the software I'm using, and I'm not going to spend hours to make it look absolutely perfect. So if you see the space vary a little bit, you get the general idea. Okay, now the fourth carton comes along, has good code, the stop drops, lets it slide down to the belt kicks on and pulls 4 cartons on. Now not only will we have a counter that counts how many cartons will count up when a carton comes onto the middle conveyor, the buffer conveyor, and will count down when one goes off. So not only have we counted 4 cartons onto this conveyor, but the first carton on, which is the first one out, so that's the first in, first out, FIFO, is now blocking 3PE. So we know the conveyor is full both by the count and by the fact that 3PE is blocked. And of course we don't dare turn on that middle conveyor unless the second conveyor is turned on, because the first conveyor would push all 4 cartons down to the second conveyor. When the first one hit the dead belt, then the second carton would push up against the first and shove it a little further onto the second conveyor until they were all stacked up. We don't want to lose the space in between them. In most material handling systems, you always need to singulate or separate each item on the conveyor. Okay, so now we have a full buffer. Our buffer is full. So we bring on another carton. The code is good. It comes down to the bottom. Now we're going to go ahead and turn it on, but notice that the second conveyor pulled that carton away quite quickly. So we would not turn on the first conveyor, the middle one there, the buffer conveyor, unless the takeaway conveyor, the one furthest to the right, was turned on, thereby calling for a carton. So we'll send in another one. Code's good, stop goes down, it goes down to the bottom. Now it wouldn't turn on here unless the takeaway conveyor was calling for one. Let's do that one more time. Only this time the takeaway conveyor may want the carton right away. So the carton comes in, stop goes down, takeaway's calling for one, so it turns on and it takes them completely away. So this is the basic idea, or the sequence of operation for our conveyor that we're going to use in our lecture on using RSLogix5000 to create multiple programs. So basically we'll say that you have 10 of these conveyors in your process. It really doesn't matter what they're doing, it's just a buffer conveyor. Whether it's because you need to buffer, and by the way, remember, you can have a bit that you turn on and off. So any carton that comes down the gravity conveyor, it hits the buffer conveyor and keeps right on going across to the takeaway, and away it goes, because downstream they're demanding cartons right now. But let's say downstream they have to stop part of the process to load up more labels for the box labeler, or some other part of the process downstream that needs some attention. You can stack as many as 4 cartons onto this conveyor, and then you can start pulling them off again. Okay, let's take a closer look at the middle conveyor, the buffer conveyor. Now remember, I explained to you that we had a pulse generator that would put out a pulse every so many inches of travel of the belt. Now it's really generating pulses based on the angle of the drive roller, but we've basically mathematically equated that to so many, or correlated it to so many inches of travel, surface travel of the conveyor. So if it puts out a pulse every 2 inches and we put out 6 pulses, we know the belt has traveled 12 inches. Now the actual inches traveled per pulse doesn't matter for our illustration. It would in the real world, because you would have to pick your pulses per foot or inches per pulse, however you want to describe it, based on your carton size and length of conveyor. Another thing that we've done here is we have created an array called data buffer conveyor of 20 double integers, 0 through 19, and we're illustrating those as a virtual conveyor. So if you look below the conveyor, you'll see some vertical register values. They're all zeros right now. So when a carton hits the first photo eye, whatever barcode has been read in, we're going to put it in that first register. Then when we turn on the conveyor, it's going to start putting out pulses, and when the carton hits the second photo eye, we are going to start loading that product code into those words, and every time we get a pulse, we're going to move that to the next position. Now if the carton's still blocking photo eye 2 PE, then we're going to continue to put that code into that first position until the carton clears the photo eye, and at that point we should have a data image that looks just like our box conveyor image. So our data conveyor and our box conveyor should look very similar, and this is so we can keep track of what the product is in each location on the conveyor. Now this conveyor right here, this buffer conveyor, could be multiple sections of 20 foot each being treated all as one great big long conveyor, and we have multiple cartons. Typically when you do that, you'll find a photo eye at the end of each section and the beginning of the next to make corrections based on any slippage. So let's go ahead and run this. So here comes a carton, breaks the first photo eye, loads that code, and keeps loading it until it clears the photo eye. So at that point, our scan code now goes back to 0, because once we've loaded up those 5 registers that reflect the position on the conveyor with that product code, then we're good. And of course the conveyor stopped, the carton's sitting there. So now we bring in another carton, and well, I'm sorry, we don't bring in another carton, but as we move the carton down the conveyor, notice that the product code moves with it through the virtual conveyor. That's really all I wanted to illustrate. I thought about adding more animation to show 2 cartons on there, but I think I'll just leave it at this. So when the belt turns on, we start getting more pulses. So if you watch 1PG6, there, the pulse generator, you'll see that it is pulsing and moving the data between the registers. So now that carton occupies data buffer locations 7, 8, 9, 10, and 11, where it originally was 0, 1, 2, 3, 4, and 5. So we have a 2 register gap between where the carton was and where the carton's at now, but I think you get the general idea. Okay, back to our program. So we're going to start creating some logic now for the conveyor system I just showed you. So the first one we're going to do is we're going to create a second routine. So we go to main program, right click on main program, new routine, and we will call this routine box conveyor. We're going to leave it ladder diagram, and we're going to leave it in the main program. Now we're going to open this up, and notice when you open an empty routine, it always gives you a fresh, unfinished rung. So we're going to use an equal first, so we'll go up here to compare, and we'll pick an equal instruction, and we're going to type in code scanned, C-O-D-E-S-C-A-N-N-E-D, code scanned. And then we're going to type in for source B, code product run, code product run. So for this instruction to be true, the code that was scanned has to equal the code that we're actually running right now. And then we're going to say, all right, if the code is correct, then we want to go to bit, true if on, and type in PE gravity exit, PE underscore gravity exit. So this is our exit, the exit photo eye for the gravity conveyor. And actually, you know, those photo eyes are using a reflector. So you can make them light operate or dark operate. I think I'm going to change this instruction to be a true if off, meaning that if there's nothing blocking the eye, then this will be true. In other words, if something's blocking the eye, then this will be false. So I don't know if you're familiar with photo eyes or not, but most of them you can select light operate or dark operate. And they give you the inverse operation as far as it being a switch. And it's the difference between it turns on if something blocks the photo eye, or it turns on if nothing's blocking the photo eye. So in this case, we're going to use a true if off because we're looking at the conditions in order to release the stop. So if this photo eye is clear, meaning it's off, therefore this would be true. So we'll add another one. We've got another photo eye, the second one. That is PE underscore buffer entrance. And I hope I'm spelling those correctly. I'm going to bump the geyser button here a little bit, make it a little bit bigger. See the geyser button up there, the zoom in? That's if you're a geyser, you need to zoom in. And I think I'll collapse this a little bit because we don't need all this project view over here. And remember I told you that 4 is how many cartons or containers we want on the buffer conveyor. So I'm going to add another true if off, and I'm going to make it CNT underscore box buffer dot DN. Now that counter doesn't exist yet, so we won't be able to define this tag until we actually add the counter. Then I'm going to do an OTE here, and we'll call it SOL underscore gravity stop. So it's the stop on the gravity conveyor. Okay, now we have a whole bunch of undefined tags there, and we'll just leave them undefined for a second, And let's go add another rung, and we're going to have a true if on, a true if on, a true if off, and another output. And we're also going to have a branch around, so I'll just grab that, pull that bad boy down there. That's what a rung's going to look like. So this PE gravity exit will be there, and the buffer entrance will be on this true if on instruction, and this will be the same done bit for that counter. And then we'll call this motor underscore buffer conveyor. Now we got even more undefined tags. Let's add another rung. We have a true if off, and we're going to use a one shot and a count up instruction. We have another tag here, box gravity to buffer. So box gravity to, and it's just what it sounds like. If there's a box traveling from the gravity conveyor to the buffer conveyor, then this instruction will be false, but the bit will be on if there's a box traveling to the buffer. Then for the one shot, we'll be clever and call that buffer one shot. And for our counter, we'll just grab this, bring it down to here. We'll double click, get rid of the done bit. Okay, now I think we're going to go and define some tags. So we'll start with this one right here. It's an undefined tag, new, count box buffer. Now it's a count up instruction, so it knows the data type should be counter. So all we have to do, and by the way, you want to put this in the main program. All of these tags, you want to make sure you put them in the main program and not in the controller tag database. Now if I accidentally created some and put them into the controller tag database, I can go cut them out and paste them into the program database. But it's a good idea just to put them in the main program to begin with for this illustration. So hit create. Now notice that I have zeros here instead of question marks. So I'll just make that 4. So I want 4 cartons. These tags now are good. In other words, the done bits, see, defined. And if I were to double click those and go set them again, now you see capitalized DN. That's totally unnecessary, other than it looks tidier if it's a capital DN. So these two tags are now defined. This one, buffer one shot, is strictly a Boolean in the main program, so we just hit create. This is a Boolean in the main program, so we hit create. This is a Boolean in the main program, hit create. This is a Boolean in the main program. Later on we'll go back and we'll alias these. Right now we're just defining them as Booleans. You see the E's disappear as soon as the rungs are happy. So this is a Boolean in the main program, create. Oh, that one's already created. Boolean in the main program. So we already nailed those down below here, so we need these defined yet. This is going to be a double integer in the main program, and a double integer in the main program. So now we've got 3 of our rungs for our box conveyor. Now we're going to add some more here. We need a rung to control the takeaway conveyor motor. So we're going to go new rung, we'll go to bit, and we need 2 true-if-ons and an energize output. So the first one here will be call takeaway conveyor, and this one will be the done bit for that box counter, and then this will be MTR for motor takeaway conveyor. So that's a Boolean in the main program, and this is a Boolean in the main program. Okay, these are the 4 rungs that we need to actually control our conveyor. So if we have a good barcode scanned and the photo eyes are clear at the gravity exit and the buffer entrance, and we're not already at 4, then turn on the gravity stop. In other words, pull it down, let the carton roll on down, and when it hits the gravity exit photo eye, if again we're not at 4, then this will be true. That'll turn on the motor and it'll pull it onto the buffer conveyor, blocking the entrance photo eye. So when this becomes unblocked, this being blocked keeps that motor running until it clears this photo eye, then the motor will shut off. Now there's another piece of logic that actually executes this bit so we can count up 1. And then of course if the takeaway conveyor is calling and we have 4 on the box buffer counter, then we'll turn on the motor to take them away. It's that simple, really. So now we want to create another routine, and we want to call this one data conveyor. And I think what I'm going to do, I'm going to open this one up, and I'm going to put in 1 rung of logic just to get started. So I have a true-if-on, I have a one-shot, I have a move, which is really a word copy. When you move something, it's not where it used to be. You moved it to a new location. An MOV instruction, we couldn't call it a copy instruction because that instruction was already used for a file copy, COP. So really an MOV, move, is really a word copy. It copies it from the source word to the destination word. And so we'll put code scanned in here. The tag's already in there, so once I see it, I just hit enter, and then this one will be code released, and we'll define that new double integer main program. Okay, this will be the solenoid for the gravity stop. You see that tag's already in there. This will be the scanner one shot. Which is a new tag. New, base, Boolean, main program, create. Okay, rather than have you set and listen to me add the rest of the logic for our data conveyor, I'm going to stop recording. I'm going to enter in the code and then come back and explain it. But if you look over here, you'll see I have a main conveyor, a main routine, a box conveyor, and a data conveyor. the box conveyor routine is actually going to control the movement of the boxes on the conveyor. This subroutine is going to control the data moving through the virtual conveyor that you could almost say is parallel to the real conveyor, where we're keeping track of product codes. Now, this is the only routine that will run if we put this in the run mode. So we need to go to main routine and add a couple JSRs. Now, I can go find the JSR, but it's been so long since I've done it this way, I'm not even sure what tab it's under. However, what I normally do is I just go to the head of the rung, double click, so I open up my ASCII entry here, and I just type JSR space JSR. Enter. That gives me 2 JSRs. And then I'm going to double click here on the routine name and pick box conveyor for this one. Double click here, drop down the list, and pick data conveyor for that one. So now I have a rung in the main routine that will execute this instruction. It'll jump to the box conveyor, run all of this code, and then come right back to here, go to this instruction, go to the data conveyor, run this code, back to here, drop down to the end rung, and start over again. So it'll run the box conveyor code, the data conveyor, box conveyor, data conveyor. Now, I could have put all of this in one routine, but that wouldn't have been as good an example for what we want to do with multiple programs. So I'm going to pause, and I'll be back in a second. So you watch how fast I can put this code in. It's only going to take a second. Yeah, I know I'm real fast. Okay, a second ago when I left you, we had this one rung in there. We did not have this latch bit. So remember, this is what moves the data through the data conveyor, the virtual conveyor. So whenever we energize the gravity stop, basically what we're saying is we're releasing a carton to go down the gravity conveyor. We one-shot it just to make sure it only happens once. When the gravity stop is energized, it takes the scanned code and moves it into another register called the released code. In other words, we've released the carton, so the release code represents the carton that's traveling down the gravity conveyor down to the first photo eye. We also latch on a bit that we may or may not want to use. Remember, this is not literal code for an actual system, because there's a few more hooks that we'd have to add to integrate this into a bigger system. So we're just saying that we're going to latch that bit, and that bit stays on until we're ready to release another one, or until we're satisfied. So we release the carton because we pull down the gravity stop. We transfer the scan code into a new register, and we latch this bit. If that bit is latched, when the carton hits the exit photo eye for the gravity conveyor, then we remove that release code into the code for the gravity exit. So we're saying that a carton with that product code now occupies that spot right there at the exit of the gravity conveyor. And then we reset that release code back to 0 once we've transferred it into the code gravity exit, and we unlatch that bit. Okay, moving down. Remember, in the box conveyor, where we're actually controlling that motor for the buffer conveyor, has to do with the photo eyes at the gravity exit and the buffer entrance. Okay, so if both of those photo eyes are blocked, that means that a carton or a box is now between the gravity conveyor and the buffer conveyor. It's going across the gap. So we turn on a bit called box gravity to buffer, and we seal in the exit photo eye, because that's going to clear, that's going to go false, and we want to keep this logic going until the carton clears the second photo eye. During that whole time, we will take the code that we captured for the gravity exit position, and we're going to move it into the first position of the data buffer conveyor. Now remember, we got this pulse generator right here that is continually moving a length of 19 words from position 0 to position 1. So if you want to put 0 at the bottom and 19 at the top, that's a total of 20 words. We're basically taking 0 through 18 and moving it to 1 through 19. So we're moving 19 words at a time towards the end of the conveyor, one word at a time. Okay, when we have cleared that photo eye, then we reset the code in the gravity exit also. So that leaves it empty waiting for the next carton. Might be different product code. Okay, so this is the pulse generator that's moving the data. As long as the motor's running, this is going to be putting out pulses. It's going to move the data. Okay, now let's say that we want to, our code back here in the box conveyor is going to run the takeaway motor. If the buffer exit photo eye and the takeaway entrance photo eye are both blocked, it turns on this bit, box buffer to takeaway, meaning there's a box traveling across that gap between the buffer conveyor and the takeaway conveyor. It seals itself in, and it's going to keep moving the data value or the product code from the last position in our data buffer conveyor to the first position in the data takeaway conveyor. So as we're transferring the carton from one conveyor to the other, we're transferring the product code from one data conveyor to another. And of course, we use the pulse generator from the takeaway conveyor to keep moving 19 words from 0 to 1. That means 0 through 18. We're taking those 19 words and moving them to 1 through 19. You can't move all 20 because you've only got 20 places, and if you move all 20, you've got no place for the last one to go. So we have a double integer array of 20 elements. We're moving 19 at a time, almost like a walking beam conveyor, if you're familiar with that. And then of course, last but not least, we want to be able to update the preset on our counter that counts the number of boxes into the buffer. Okay, now the one thing I didn't see here is the countdown. So we don't have countdown. So it looks like you're going to see that added hot here. So we'll go here and, well, we'll put it right after this one. So we add a new instruction, a new rung, and whenever the photo eye clears for the buffer, whoops, PE takeaway entrance. In other words, when that photo eye clears, meaning when it goes off, then we're going to count down this counter. That's all there was to it. So whenever a carton leaves the buffer conveyor and goes by that fourth photo eye on the takeaway conveyor, when it clears during this false to true transition, we're going to count down that buffer. Okay, that was one rung of logic that I forgot. Okay, so now we've got our logic done. Next step is we're going to have to alias the actual tags that are real world bits. In other words, like this photo eye gravity exit, well, that's just an internal tag. We need to alias it. So we'll pause a second and I'll be right back. Let's alias. We go to the main routine, there's nothing there to alias. Go to the box conveyor and we'll go up to the first one here, the photo eye gravity exit, data type Boolean main program. I'm going to right click, edit, there's my tag. I'm going to change it to an alias for, drop down here, now I'm going to click on program because I want to get rid of the program tags. So all I'm looking at is the I/O tags or the controller tags. Slot 1 is our input card. Expand that, click on data, see the little arrow, drop down the list and pick bit 1. So photo I, gravity exit, is now an alias for the actual input bit, which we would have that photo I wired up to. So we'll hit apply and OK. See, now we've got an actual I/O. Do the same thing here. Edit. Instead of a base, it's an alias. Alias 4. I'm going to click on program to get rid of the program tags. Go to data, drop down the list, pick 2. On here and hit OK. Now this is an output. Solenoid. Gravity stop. So you notice that I tend to capitalize real world devices. PE, SOL. I probably should have left that little NT, but oh well. MTR for motor. So we'll go to solenoid, edit, make it an alias now, and then click on our alias 4 and click on program. Now this is an output, so I'll just use bit 1. We could use 0, but I like 1. Okay, now we've got everything aliased here. Look, these are now alias 2 because every place that tag was used now is going to show the alias information. And by the way, if you're doing this and you don't see any alias information, go up to Tools, Options, and Display Show Tag Alias Information is under Display, under Options. Okay, now this motor, that's a real world device. We have to alias that. Alias 4, and we're going to go down here and click on program. This is an output, slot 2, see local, slot 2. We don't want the configuration, we don't want the data that comes back from the card, we want the output data for that card in slot 2. Data, and we've already picked 1, so we'll pick 2. Apply and OK. Now that's doesn't need aliased. So the motor for the takeaway conveyor, that needs aliased to an actual output device. So we'll make this an alias, alias 4, turn off the program tags, expand slot 2 output, select data, drop down the list and pick 3. Apply and OK. After a while you get really fast at this. Okay, so that takes care of our box conveyor. Everything is aliased. Now let's go to the data conveyor and see what all we've got here. Photo I, photo I, photo I. Okay. Our pulse generator needs aliased. So, and that, we'll turn off the program tags. That's an input, slot 1, I, data, and it is five. Okay, our photo I buffer exit, we have to alias that to an actual input. Alias, drop down the list, turn off the program tags, it's an input. And I have, for the buffer exit, I have assigned bit 3. That's what I have wired up. In other words, you'd be using electrical print to aliases. That's one thing that's really sweet about RSLogix5000, Control, Compact, Logix, etc., the Logix Engine. You can go through and write all of your code without knowing what your I/O addresses are, your I/O memory locations, and then later on go and alias them like we're just now doing. So the PE for the takeaway entrance, that photo I, we're going to alias that, turn off the program tags, that's an input, collect data, drop down the list, and I've got that for 4. On my print, select OK, and we ought to be getting pretty close, if not finished. I think we're done. We are done aliasing. Okay, now main routine, box conveyor, data conveyor. I didn't really explain all this, but I'll just give it a shot real quick. When we drop the solenoid, or we energize the solenoid to drop the stop, we move the scan code into the code released. That means the carton's released going down the gravity conveyor where we latch on the bit. Actually, I see now we did explain this much already. Once it's released, when it hits the exit photo I for the gravity conveyor, it moves it from code release to code gravity exit. Now it might sit there for a while if the buffer conveyor is not taking any more cartons, and then we clear the release code and we unlatch the bit. But if another carton comes along and is scanned in, it won't be able to drop the stop until those 2 photo I's are cleared. In other words, that carton's cleared out of there. So we go a little bit further here. So if the gravity exit and the buffer entrance are blocked, then we have a box going between the 2 conveyors, and we shift the code into the data buffer. And I realize now I already explained this, but I'll just finish it. When that goes false, then we clear the gravity exit. And then we use our pulse generator to keep moving 19 words 0 through 18 to the new position 1 through 19. So you could just look at a stack of 20 spaces, and we're taking everything in 0 through 18, 0 through 18, pulling it out and shifting it up 1 position and putting it back in. And of course, we keep moving the product data code from the last position of the previous conveyor into the first position of the next. Okay, we're going to pause, and I'm going to then move on to creating multiple programs. But here's the deal. We have 10 of these in our system, 10 conveyors like this. It could be 20, it could be 7. But we have multiple conveyors, and they are identical. Now, the data images are identical, but the hardware images are not. They look the same. They have the same part numbers for photo eyes and solenoids and motors. The problem is they're wired to unique inputs on the I/O cards. So controller tags, I/O cards, you can't have 2 input bit 1s on slot 1. There's just 1, and you can't share it between multiple conveyor systems. So we created this code for 1 conveyor, and we're going to test it. Not literally, but in the real world you would test it, and when it's perfect and you love the way it works, then you duplicate it. So that's what we're going to do now after a short break. Okay, let's copy what we've done for conveyor number 2. So we go up to main program, right click, copy, go to main task, right click, paste, and voila. Now, just to be clever, I'm going to go up to this program, and I'm going to change the properties, and I'm going to call it conveyor 01. To make it a little bit clearer, we'll put a little underscore. Conveyor 01. Apply. OK. I'm going to go to this one, right click. You can't see it, but I'm going down to properties outside of the view of the screen capture here, and I'm going to call this conveyor underscore 02. And I'm going to check configuration, main routine, monitor. Okay, we're good. Okay, now I've got two programs. If I go to the main task and I go down to properties, again you can't see it, it's off the bottom, but in your list here, if you go down properties and I go to program schedule, see, I have it scheduled to run conveyor 1 and conveyor 2. So you can look at conveyor 1 as one PLC and conveyor 2 as another PLC, in a sense, because each one of them is completely isolated from the other. They both have access to the controller tags, which are the I/O, slot 1 and slot 2. But they each have their own set of program tags. You recognize these: box, buffer to takeaway, box, gravity to buffer, buffer one shot, call takeaway conveyor. So all of these tags right here, and I'll double click, that's conveyor 1, see, conveyor 1. Scope, there's three things. There's the controller tags, conveyor 1 and conveyor 2. If I click on conveyor 2, see, they look identical. The tag names are identical, but the path is not. The path would be main task, conveyor 1, and then a tag name, or main task, conveyor 2, and then a tag name. So these program tags are only accessible by these routines. These program tags in here are only accessible by these routines. But both this set of routines and this set of routines has access to the controller tags, which is the I/O. Now, remember I told you that you can't use the same I/O point. So I'm going to have to go in there now, and I'm going to have to edit. Now I'm in conveyor 2 now, so I'm going to edit it, and I'm going to drop that down. We'll turn off program just to make it easier. Go to data, and just to make this look clean, we'll pick 9 because it's right under 1. Apply and OK, and then we'll do this one. You got to be really careful when you're doing this that you don't get lost. Input data, we'll make that input 10. This is what I have the wiring diagram drawn up to use these inputs. Now this is going to be an output, so we'll edit. We'll turn off the program tags, go to just the output slot 2, and we'll make that 9 as well. This gives us some spare I/O that is equally spaced for these conveyors. And we need to change that one. Turn off the program tags. We need to change this one. Turn off the program tags. That was 3. We'll make it 11. Apply and OK. This is the photo eye takeaway entrance for conveyor 1. So right click, edit. So under 4 would be 12. And I think that takes care of everything for the box conveyor. Now we go to the data conveyor, and that's an output, and that's 9. So let's turn off the program tags. Nope, already got that one done. So got that one done. Done. I think we may have a couple down here that we have to do yet. Yep. That's the pulse generator. That would be 13. The buffer exit, we have to change that one. Yes, see, it's 3 right now. And we want it to be 11. So once you realize what your offset is, then it gets pretty easy. And we're done. So look how quickly we did that. We copy pasted, changed the alias so it's alias to a unique IO point, and we're done. So in the old days this was a little bit more work, but notice that I have the exact same tag names. I don't have conveyor 2 code release bit, and then that's in data conveyor. See, I don't have conveyor 1 there and conveyor 2 there. So all of my program tags in both of these programs are identical. I don't have to recreate them in order to get them all into the same PLC. So there you go. Multiple programs, RSLogix5000. Great stuff. Hope you enjoyed this and learned something. Thank you for listening.